Alright, today we're going to talk about the area of parallelograms and trapezoids. We're going to relate these to triangles and rectangles along with talking about their area equations and how we find their areas. So let's get started, and we are going to start with the parallelogram. A parallelogram is a lot like a rectangle. The main difference is that the angles here and here and on either side don't have right angles. But we do know that these lengths are equal along with these side lengths, and that these two lengths of equal length sides are parallel. Alright, which just means they'll never intersect no matter how far they go. Now, when we're finding the area, we need to know two main things, and they're just like the rectangle and triangle. We need to know the base, which is that bottom length here. This is the base, and we need to know the height. And the height runs exactly like the triangle. We go from the top of the figure to the bottom of the figure, and it creates that right angle with the base, and that gives us our height. Now you might recognize this formula. This formula is the same as the rectangle. Area is equal to the base times the height. And we can shorthand that as B times H. So the two things we really need to know are that bottom length or that top length, since they're equal, and the height. That line forming a 90-degree angle with the base ring all the way to the top of the shape. Alright, so let's do some examples together. We need to find the area of this parallelogram. Like we talked about in rectangles and triangles, we talked about how area is composed of small squares that fill up the rectangle, and we need to see how many squares can actually that shape can fit. So first, let's look at the solid squares. You can see we have 4 full squares here. These are squares that can totally fit inside the shape. But you can see we have some leftover area, but they can't fit full squares. So we're going to fill those with partial squares. And you can see we have 8 partial squares. Now, unlike the triangle, which we talked about the other day, we can see that these don't quite fill up a half a square. The number 3 is maybe a little bit more than half, 1's definitely less than half. And so we need to figure out how can we add these together to figure out how many full squares there are. These 8 partial squares can fill. And if we look at number 1 and 3, for example, you can see that if we took the shaded area in number 1 and placed it in the open area in number 2, that would be roughly a full square. So we can say number 1 and 3 create 1 full square. Similarly, we can do the same with 2 and 4, 5 and 7, and 6 and 8. So these 8 partial squares, we can create 4 full squares. And if we add those 2 sets of full squares together, that 4 and that 4, that gives me 8 full squares. Now, the area equation allows us to do that a little bit faster and a little bit simpler, and it gives us a more accurate area. So, area is equal to the base times the height. Our base here is 2 feet, and my height is 4 feet. My base is 2 feet, and my height is 4 feet. Now I take base times height, 2 times 4 is equal to 8. And my final unit, I've multiplied the foot and the foot, so that is a foot squared. So 8 feet squared is my final answer. And you can see here that the 8 here matches well with the 8 here. That just says that we had a good estimate using our square method. Let's do another example. I want you to do this one on your own, so pause the video, do it on your own, then we'll come back together when we're done. Alright, now that hopefully you're finished, we can see that the area is equal to the base times the height. My base is 20 inches, and my height is 15 inches. From here, we can say that 15 times 20 is equal to 300. And so if my final answer is 300 inches squared. Or Or sometimes you might hear square inches, 300 square inches. That's the same thing. So don't forget your units, and hopefully you got 300. If not, feel free to rewind the video and go for it and see where we made our mistake. Now let's talk about the trapezoid. The trapezoid is a little bit more complex of a figure. It has three things that we need to know. The first thing we need to know is this bottom length, which we're going to call base 1. Now, unlike the parallelogram and the rectangle, you can see that our parallel bases actually have two different lengths. So we're actually going to need to know the second length here, which is base number 2, or base 2. The last thing we need to know is what we need to know in every shape so far, and that's the height. The height is that going from the top of the trapezoid to the bottom and forming a 90-degree angle with each base. And that is my height. From here, what we're doing is we have the area, and we set that equal to 1/2 base 1 plus base 2 times the height. Alright, and we can shorthand this as 1/2 B1 for base 1, B2 for base 2 times the height, or H. Sorry. So, you can see here, there's our right hand shorthand there. You can see that what we're actually doing is we're averaging our bases. B1 plus B2, and since we're adding up two bases, we divide it by 2. We take the average of the bases and multiply it by the height. That's how we get the area of a trapezoid. Let's look at some examples for this. To find the area of this trapezoid, first thing I want to do is I want to use our squares again. So we're going to add up the number of full squares we have. And you can see here, we've got roughly 13 full squares. We have 13 full squares. Now we want to see how many partial squares we have. And you can see here we're going to have roughly, I think 10, we have 10 partial squares. And this one's a little bit harder because it's kind of hard to see which squares do we need to add up to get our full squares. So take a look and see which squares you think we need to add up. At a first glance, I say probably number 1 and number 9 add together, those shaded regions add together equal 1 full square. Similarly, I think number 2 and 10 are the same way. Also, if we look at maybe 3 and 4, those are pretty close. The same with 5 and 6, those are pretty close. And 7 and 8 each look like they take up just about half. And this is a perfect possibility, but we're going to estimate it as maybe 5 full squares from those 10 partials. It doesn't always equal the number of partial squares divided by 2, but that's the way it's been working out for us lately. Now if I take those 2 sets of full squares, then we get 18 full squares. The area equation allows us to do this a little bit more accurately, and I think a little bit faster as well. So we say the area is equal to 1/2 B1 plus B2 times H. And we have 1/2. My base 1 is the 6 meters on the bottom. My base 2 is the 3 meters on top. And my H is the 4 meters. And that 4 represents a line that goes from the top to the bottom and forms a right angle with each of these bases. So following the order of operations, we have 1/2, 6 plus 3, we have to do our parentheses first. 6 plus 3 is equal to 9 meters and 4 meters. Then we like to multiply our whole numbers first. So 9 times 4 is 36 meters squared. And then if we take 1/2 times 36, that's the same as 36 divided by 2, and that gives me 18 meters squared. And that would be my final answer. And you can see this 18 matches this 18. We just have one more example to do together. I want you to go ahead and try this one on your own, then we'll do it together and see how it goes. Alright, let's get started. You can see real quick, I want to show you that our trapezoid here actually can be broken up into a rectangle and a triangle. We're not going to solve it this way right here, but I did want to show you how we can use these two shapes to make a trapezoid. And this would just be one example of one trapezoid, how we can break it up. Let's go ahead and solve the area together. The area is equal to 1/2 B1 plus B2 times H. I copy down my 1/2. My base 1 is 12 meters. My base 2 is 7 meters. And my H is this 9 meters over here. Again, following the order of operations, I take my 12 plus my 7 first. And that 12 plus 7 is equal to 19 meters. And then I copy down my 9 meters. Now I just need to take 19 times 9. 9 times 9 is 81. I carry my 8. 9 times 1 is 9, plus 7 is 171. So that gives me 1/2 times 171. And I've multiplied those meters already, so that's meters squared. Now from here, I take 1/2 times 171. 171 times 1/2 is the same as 171 divided by 2. So I take 2 goes into 17 8 times. That gives me 16. Get 1, carry down the 1. 2 can go to 11 5 times. Carry over my decimal. 5 times 2 is 10. Get a 1 left over. Drop the 0. And 2 go into 10 5 times. So my final answer is 85.5 meters squared. And what this tells me is I can fit 85 full boxes, full squares, inside this shape, along with an extra half box. And you can see this is a lot faster than if I would make 1 by 1 boxes and fill it up and count them the entire time. Well, hey, that's all I have. Hopefully you're understanding. If not, feel free to rewind the video to any point and go over those things. And hopefully you'll have questions that you can ask tomorrow in class. All right, have a good evening. See you tomorrow.